All right, I believe we are recording. The recording has changed from how it used to be too. So also when I record, it pops up with something. There's a little bar that goes across it. So I'm going to wait a second. There, it should be gone now. If it's gone on my end, it should be gone on yours. So the one that's under the midterm and final review tab is very, very similar to what you're going to see in your actual midterm. So I just want to work through these and answer any questions you have, and then I'll stop the recording, and then we can do any extra questions you may have beyond that. So question one is definitely like one on the test. Like I said, I've graded about 7 or 8 tests so far, so I have a better idea of what's on it. This one says there are 2,500 pet owners represented by the circle graph. How many pet owners would you expect to be represented by cats and by hamsters? So this is asking how many. So I find the cat piece of the pie, and that's 21%. What is 21% as a decimal? 0 point what?
21.
21, beautiful. And then I'm going to multiply that by the 2,500 because that's how many people were surveyed total. You can do this on any calculator. You need a calculator with you. It can be a graphing one. It can be a scientific one. I'm just going to use my cell phone one right now. You cannot use that on the test. So 0.21 times 2,500. I got 525. Does that agree with what you're all getting?
Mm-hmm.
Okay. I love to make sure we can confirm things. Now we're going to do the same thing for hamsters. So hamsters was 6%, a smaller piece of the pie. What is 6% as a decimal?
Would it be 0.06?
Perfect, perfect.
Okay.
That's probably the hardest part of this problem. And then we're still going to multiply that by the total number of people surveyed. So again, I can do that on my calculator. Again, you need a calculator of some sort with you. It needs to either be a little scientific one or a graphing one. You cannot take your cell phone in there. It'll make you lock it up. So we're going to do 0.06 times 2,500. And I get 150. Does that match with what you're all getting?
Yep.
Good. Questions so far? Now we're going to do the same thing in part B, but with the degrees. So I'm still using the same decimals I figured out from the pie in part A. So I'm going to do 0.21 times, how many total degrees are there in a circle?
360.
Yep. So you're always, that's one thing you do have to know, that there's 360 degrees in a circle. So 0.21 times 360, I get 75.6, and then I have to read the directions, round to the nearest whole degree. So is 75.6 closer to 75 or 76?
76.
76, perfect. So do read every question and see what they're asking for in terms of rounding. Midterm will look very similar to this. It is a little shorter. There's not as many parts. I think there's about as many questions, but it's still taking people about an hour. So it's maybe an hour and 15 minutes, and you have 2 hours to take it. So the same decimal as the hamster, 0.06. And then we're still going to multiply that by the 360, the total number of degrees in a circle. Times 360. I got 21.6. Does that agree with what you're seeing?
Yeah, which would be 22.
Yep, beautiful. Questions on number one? All right. I like that one. I know there's one similar to this on the test. I can't remember if they do the degrees or just the population, but knowing it's good. At the bottom of page 1, they have these examples. They want us to rewrite them without addition. They don't want the answer. I know we could all figure out the answer to this by putting 3 plus 3 plus 3, etc. They want to know, how can I write this as multiplication? Repeated addition can be written as multiplication. That's actually the definition of multiplication. So for the first one, I'm looking, I have 3 that's being repeated. How many times is it being repeated? How many times do you see the 3?
6.
6, yeah. You could do it with parentheses. You could do it as 6 dot 3. Or you could even go old school and do 6 times 3 with the x. You see we start to move away from that a little bit because x becomes a variable. The higher up you go in math, x is not usually used as a as a time symbol anymore. What number is being repeated in the middle one in number 2?
21.
21, and then tell me how many times you see it.
7.
And again, they don't want the answer. They just want you to write it, what it means in its shortened form. What's being repeated in the last one on this page?
15.
And how many times do you see it?
4.
4. Beautiful. Questions on number 2?
Mm-mm.
All right.
Perfect.
Number 3 is very similar. I am going to write out the middle one, and then I'm going to pull up the answer key for the other two because I wrote them out earlier, and I can't write that small. So this one is exponents. So it's not repeated addition now. It's repeated multiplication. So the middle one, it says 5.55 to the third power. Again, they're not looking for the answer. They just want to know what it means. Well, it means that I multiply 5.55 by itself how many times?
3. What's that?
Like I said, I'll do this one because this one
3 times.
fits on here. Questions on what we did there? And again, you don't have to use the parentheses. You can write the X. You can do the dot between them. You can use a little asterisk if you like. Question?
Will the test be writing, like, will it be
It's
paper and pencil?
Yes, paper, pencil. Don't open the computer. Apparently, there's sitting people at computers. Do not open the computer. You do not need the computer, and they're flagging people for cheating if you do.
Oh, Lord.
Usually, they have a classroom. This was kind of new. So just make sure you take in a pencil, you take in your calculator, and you need a photo ID. They will give you the paper test, and then they'll give you scrap paper, and then they'll staple it all together. I'm picking up tomorrow around 1, and then Friday again around noon, and then Monday again around noon. So depending on when you take it, I'll pick it up one of those 3 days. I think they're just getting pressed for space. All right, so for the other two in question 3, I was going to bring up the answer key. Like I said, because I wrote that one on paper pencil, and it's a lot neater. So you see in number 3, we wrote the 1.89 out 7 times. And again, I showed some different ways of writing. You can do the parentheses, you can do the X, you can use the dot if you want. A lot of people don't like the dot because it looks too much like a decimal point, but I'm okay however you want to write your multiplication. 4.31 is repeated 6 times. Any questions on number 3? I have more fun colors than doing that one too. All right. I like to do the work with you, but sometimes it's just to watch me write it out 7 times is not fun. Question number 4. I love that we've added rounding to the test. I think it's very valuable because we do a lot of rounding in here. These are all being rounded to the nearest tenth. Tenth means one number after the decimal point. So that would be the 6 in the first one. And again, I have trouble writing that. See, it didn't even underline the right part. I have trouble writing that small. 6. It's not writing. 6, the 0 in the second one, and the 7 in the third one. And then you look at the number after the one you're trying to round to. So when I'm rounding the 6, I look at the number after it, which is a 7. What does the 7 tell the 6 to do? Does it stay a 6 or does it become a 7?
Becomes a 7.
It does become a 7. So what you're looking at, the number that's the boss is the one after the one you're trying to round. And if the boss is a 5, 6, 7, 8, or 9, it will tell the number to go up. If the boss is a 0, 1, 2, 3, or 4, it stays the same. I used to say it goes down. It doesn't go down. It stays the same. Mm-hmm. So for example, the next one, we're trying to round to the 0. The boss of the 0 is the 1. What is the boss telling the 0 to do?
Stay.
Yep, stay the same. And the last one, we're trying to round the first 7. The 7 after it is the boss. What is the second 7 telling the first 7 to do?
Go up.
Go up, yeah. Questions? All right. I don't like using red, but it shows up more on that part of it. Number 5 is when we start talking about probability. You'll see the probability notation here. Probability of winning equals. So we got to figure out what information they're giving us. They told me how many games they won and how many games they lost. So there's one piece of information I'm missing. We'll talk about that in a second. I want to take the wins over the total. How many games did they win?
14.
14. I'm actually going to write this out so you can see where it's, because I can't remember if I did an answer key or not.
Wow.
And then the trick is, how many total games did they play?
23.
23. How'd you get that?
14 plus 9.
Perfect. So it's very easy to, if you're rushing through a test or you're nervous, to say, oh, it's just 9 out of 14, and kind of not even really think about what you're doing. It is 14 out of 23. They did ask me to do it as a decimal. So fractions become a whole lot easier in our world if we recognize that all the fraction bar is division. So 14 over 23 just means 14 divided by 23. And I get a whole bunch of decimals here. I'll go ahead and write them out so we can talk about the rounding. 0.608. 696. I think I got them all. Does that match what you're getting?
Yeah.
Awesome. I figure if more than one of us gets it, we're right. They asked me to round to 2 decimal places for the first answer. So they want to round the 0. What does the 8, who's the boss, tell the 0 to do?
Go up.
Go up.
Go
So
up 1.
Yep, 0.61. Perfect. Part B just wants you to write that as a percent. So to write that as a percent, you can either just move the decimal point 2 places to the right or just multiply by 100. So the chance of winning is about 61%. And some of that would actually depend on when you round. And I don't really remember what I did on the answer key here, so I'm going to take a peek at it real quick. Yeah, I did round. So you're using this answer to do it. I always struggle with like a multiple choice test because I can argue several different points. Like if we had rounded it later, it would have been different, but go with your part A, turn that into a percent. And then they do ask us if it's empirical or theoretical probability. Again, I'm going to come back to the answer key. It's a very short answer, but it's much neater than I could write on the screen. This is empirical because we're basing it on data or observing how many games we won, how many games we lost. This is not something we could easily do theoretical for because we really don't have a system in place that would say, oh, well, if it's not like we're flipping a coin. Heads they win, tails they lose. So this is going to have to be empirical. Questions on that?
Based on
Data or observation, yeah. Theoretical would be more mathematical, where you can tell, like a coin. There's 2 options, tails is one of them. The ones that we don't have a good way to do mathematically are usually empirical or experimental. So it's the same word. All right. I can write this one out for you. Any questions through 5?
No, not so far.
Good, you guys are doing great. So the next one says the government's annual revenue is 3.49 trillion. I do not believe this one shows up in the test. There's something with scientific notation, but it's not this tricky. Because trillion is one that I even have to think about. I actually had to look it up earlier today. It is 3.49 times 10 to the 12th. That would have been my guess because I know million and billion. I figured trillion was next. So I had a good guess about that. And if I was taking the test, that would have been my guess. I think the one on the test is easier. That doesn't look like a times. There we go. Now they want to take that number and divide it by 365. So I'm going to show you on the calculator. I'm going to remind you again how we can do scientific notation on here. Second, quit.
Can you, real quick, I'm sorry.
Oh, you're fine.
The 10 to the 12th power, but can you just go over real quick how you got that? Like if it didn't say trillion and it said million.
Billion, so I'd actually have to write it out. I'd have to say, okay, here, let me come back and do this. If it was billion, I'd say 3,490. And if I stop there, that's only 3,000. That's not good enough.
Right.
That's only million. That's not good enough. There's billion. And I'd have to actually count it that way. And then once I see that, I can say, oh, it's 9. It always goes up by 3. So 1,000 would be to the
So you're just
power.
counting.
Yep. So you assume the decimal was at the end of the number. We have a few more of these coming, aren't quite so big. You assume the decimal's there, and we're trying to move it so it's here.
That's right. Okay, now I remember. I'm like, I remember doing this, but
And
my
the one
brain
on the
is
test
stuck.
is not as hard as trillion, I promise.
Okay.
It was just an
Cool.
odd one.
Thank you. I just wanted to wrap my head.
No, it's fine. It is a good idea to recall how we enter scientific notation in the calculator. If you're using a graphing calculator, it's probably an EE button. On this calculator, it's above the comma. If you look above the comma, so the comma is above the 7. We go from 7 to comma, and then right above that says EE in blue. That's my scientific notation button. So if I want to enter this number, it turned off again already on me. Look at that. Oh, no, it didn't. Okay. So I'm going to enter 3.49. It was really laggy earlier. Let's see what it is. And since it's blue, I know I need to hit the second button. Second, comma will make an E show up on my screen. That E is a built-in times 10 to a power. You don't have to do anything else. You don't have to do the times button. You don't have to do the tens button. You don't have to do a power button. You just type in whatever power you wanted. And if you hit enter, it's not going to do anything because it's too big for the calculator to handle. And then in part B, we want to divide that by 365 because we're trying to figure out how much this is per day. And we get a really long, obnoxious answer. And I'll pop over to the review sheet real quickly because, again, writing this out is crazy. The one on the test is nicer, I promise. I did do the answer keys for the test, so it's a really big number, and I did convert it back into scientific notation because the problem asked me to. So if you don't see a decimal in a number, it's assumed to be at the end. It was assumed to be at after the last 6 in that number. And then I know I want it to be between 9 and 5. I want one number to the left of my decimal point. So just to show you real quickly, I can't write on this one. Never mind, I can't write on that screen. If I hadn't gone far enough, if I had 95.6 whatever, that's not far enough because 95 is too big. I want a number between 1 and 10, but less than 10. If I go too far, I'm going to have 0.956. That's too small. That's smaller than 1. You always have to have one number to the left of the decimal point. And then once you determine where it is, you just count where it was to where you want it to be and how far did you have to move. I don't remember this one being on the test. I think the next one, the next scientific notation one that comes up in a minute is. This one's just big. It could be, I've only done a few. Questions through 6, I've only graded like 7 or 8. We have a few more coming up, scientific notation, so we're good. Question 7 goes back, oops, I'm on the answer key. Sorry. Try not to give you spoilers too soon. Some of the ones, like I said, are easier to do it that way, but 7 and 8 go back to chapter 1.9. It was the stuff on statistics. For those of you going on to statistics, you'll see all this stuff again. So the first one, number 7, says, how much data do we have? Well, I had 46 people who answered something about book A, 25 people who answered something about book C, or B, 13 people who answered something about book C. So the total number of people surveyed is just adding up all those numbers. So you're going to get your calculator out and do 46 plus 25 plus 13, 84? Is that right? Good. Number 8 is a stem and leaf plot. It's an odd one just because it has like this, it's in thousands. Usually you see that it's like 1 leaf 2 would be 12, 15, 20, 21. It's not because this means in thousands of copies. So 1, 2 actually means 12,000. And maybe it's because I'm not super familiar with stem and leaf plots, but I find it so much easier to write the data out. I just don't read these very well. I know how to read the key, but I liked writing them out so I could see what the actual raw data was. So when I had a stem of 1 and a leaf of 2, that meant 12,000. Stem of 1, leaf of 5 meant 15,000. 20,000, 21,000. Questions on where those numbers are coming from? And you notice we wrote the 34,000 out twice because there were 2 4s for leaves. Once I have the data written out, I think the questions are easier to answer. So there are questions on like writing those numbers out from the stem and leaf plot. Then they ask you some questions. They ask, how many newspapers lost 34,000? Well, we circled the 2 34,000s. There were 2 of them. How many lost less than 40,000 copies? Those are all the ones highlighted in yellow because those numbers are all less than 40,000. How many got lost more than 200,000? That's the ones in green because those are the numbers that were bigger than 200,000. That's why I think writing these out is so much easier than trying to read it from here. I would be lost.
Oh, yeah.
I just haven't used them a lot. I think the more you use them, probably the more, it's just a shortcut way of writing this data. And probably the more you use it, the more comfortable you get reading it. But this one's a weird one. Most of them aren't quite, they don't usually multiply by 1,000 afterwards. They're usually just the number you have. Questions on 8, though? I think once you get the data out, it's kind of fun to answer the questions.
Yeah.
Feel good? All right. That's 8. 9. I love 9. Mean, median, mode. Mean is what you're used to doing when you find the average. You add up the numbers, divide by how many there are. So we're going to do this way, and then I'm going to show you how your calculator will do it. So I'm going to take 12 plus 13 plus 9 plus 12 plus 15 plus 15. And hopefully someone's adding with me. I got 84. Can anyone confirm that?
84.
Awesome. How many pieces of data were there? How many, whatever these are, quiz scores?
7.
7. So then for the mean, take 84 divided by 7. What do you get?
12.
Beautiful. Let's talk mode first, because mode's a little bit easier than median. Median's not super bad, but mode is the most occurring. What number shows up the most? There's two of
12
them.
and 15.
12 and 15, good. I'm so glad you mentioned both of them. So you'd list both of them. They are both modes. If everything in the problem occurs the same number of times, everything shows up once, everything shows up twice, everything shows up 3 times, there would be no mode. You're looking for what stands out because it occurs more often. Questions on mean or mode? The median literally means the middle number. If you have an odd number, it's easier because you get to a middle number, you're done, which is going to happen here. And then when we do B, it'll be a little different. You can write the numbers in order if you want, or you can cross off high and low pairs. Out of the number of the quizzes that are there right now, what's the lowest score?
8.
8.
8. What's the highest?
15.
All right, so I'm going to cross that off. I'll do each pair in a different color so you can look back at it later and see where it's coming from. I think it's done like that on the review too. What's the highest of what's left?
15.
15. What's the lowest of what's left?
9.
9.
Perfect. I have to do this one more time and then we'll be there. What is the highest of what's left?
13.
What's the lowest of what's left?
12.
And it doesn't matter which 12 you cross off because you still have a 12 left.
Cool.
Middle number. Part of why I don't do them in order is because if I do them in order, I'm going to have to check them off anyway. So I'm like, I might as well just cross them off as we go. We did learn how to do this in the calculator. You do not have to do this in a calculator. It's just an extra tool. If I had a graphing calculator on the test, I'd probably do it both ways. Everything that you want to do in terms of statistics is under the stat button. Stat button is to the left of your gray arrows. So you're going to push the stat button. And the first thing you're going to do is edit. We want to type a list in. You probably have something typed in from last time we did it. I happen to have this list typed. I have this one typed in. If you have something weird in there, use your arrows to go up and highlight the list number and then hit clear, enter, and it'll clear the whole list out for you.
Cool.
And then type the list in. I'll go ahead and clear it. I wasn't going to, but we'll do it. Clear, enter. There we go. And then you type in each number. So I type in 12 and I hit enter. 13, enter. Oops, I messed that up. 13, enter. I haven't crossed off, which may make it hard. If I type something wrong, tell me, please. 9, 12, 15, 15. I always say the calculator is only as smart as I am. If I type something in wrong, it's going to use what I typed in. Questions on entering the list? Feel good about that? All right. Now we're going to go back to that stat button. But this time I don't want to edit something, I want to calculate something. So I'm going to arrow over, and the only things we're going to do this whole semester are number 1 and number 4. Number 4 won't happen until the final. So we're doing number 1 this time. We're going to hit enter there. Hit enter a few times until it gives me some answers. And look at what the very first number is there. What's your mean? It's your average. And if you scroll down, you'll get to median. So I'd probably use this as a check. If I was taking the test, I'd probably do it by hand, like the way we did it manually first, and then see what the calculator says and see if they agree. It will not give you mode. Questions so far? All right, so now for part B, he has another score. So we have the same whole list of scores, so I can go ahead and write those real quickly. So we had 12, 13, 9, 12, 15, 15, 8, and 14. He took another quiz, or she took another quiz. I don't know if we're talking about a male student or a female student. Questions on where that's coming from? Okay. So you find the mean again, and you can kind of shortcut it. You can do it all over again, add them all up. What I know is going to happen is it's going to add 14 to what I had. So let's do this in purple. It's a different one. So instead of 84, I'm going to have 98, and I now have 8 pieces of data. So go ahead and divide that out and tell me what you get. I think it's 12 point something.
12.25.
Perfect.
Mm-hmm.
Good. Any questions on that? Your median or your mode is not going to change. Let's go through and find the median. So we still have the high of 15, the low of 8, high of 15, low of 9, high of 14, low of 12. I'm sorry I didn't do those in different colors. I apologize for that. Now I have 2 numbers left. So I have to add those and divide by 2. So it changes the median just a little bit. So it's going to be 12 plus 13. And then divide that answer by 2. What do you get?
12.5.
Yep. So I'll put those in purple up here, and the mode stays the same. It's just interesting to see how different pieces of data change things. Questions? I think those are kind of fun. All right. There is one like 10 on there, I promise. Independent and dependent. I think the easiest way to figure these out is read the sentence both ways. So does your blood pressure depend on how much time you exercise? Or does the amount of time you exercise depend on your blood pressure? Which one makes more sense? They both can kind of make a little bit of sense, but which one, especially if you're in the medical field, makes more sense?
A person's blood pressure depends on the time of
So
exercise.
blood pressure, I did this earlier this way, we'll do it this way. Blood pressure is dependent. And the
That's
part
right.
that you can control, the independent part, is how much time you spend exercising. It's the better of the 2 sentences. Some people could argue the other one makes sense, because if I go into the doctor and they say, hey, your blood pressure's high, I may start exercising more, but we'll see. Would it be maintained? Maybe not. Questions? That one's on there. The next 2 are very similar to each other, 11 and 12. 11 just happens to be a formula that's kind of recognizable. So it's the perimeter of a rectangle. And all you're going to do is replace L with what it's equal to and W with what it's equal to. I tried to highlight earlier, and the highlighters don't work on the type part. So I'm going to rewrite this formula as P equals 2, but that instead of L, I'm going to put what? What's the part I've circled in pink there?
5.2.
Yep, perfect. I'm keeping in dark green everything that stays in the formula. And then in light green, what do? I want 2 times what? What's the W get replaced with?
4.3.
Perfect. Now at this point, you can type it in your calculator. Let's get out of there. I had trouble typing this earlier. 2 times 5.2. I just have to go slower than the calculator does. Plus 2 times 4.3. See, I typed the point and it didn't come through. Your calculators will not give you those issues. I think we're good now. Get 19. Do you agree?
Mm-hmm.
Perfect. Questions on, it's called evaluating a formula. 12 is very similar, but 12 we're going to be evaluating expressions. Same idea, we're going to be replacing x with 3, y with -2. So again, I'll keep stuff in dark green that we're not replacing. So I have 5, and then the fraction bar stays the same. Everything else is going to change. What goes in place of y?
-2.
-2, perfect. And what goes in place of x on the bottom?
3.
Perfect. You can throw it in your calculator, you can do it by hand. They do want you to leave it as a fraction. They do not want decimals for this. So in that case, I'd probably do the whole top, do the whole bottom, and then see if it simplifies. What's 5 times -2?
-10.
-10. And then stays at 3, and you're done, because that doesn't reduce at all. Questions? So let yourself stop when it's done. Second one is 3 times, what am I putting in place of the x?
3.
Perfect. And that one is tricky because whenever they throw the second one in first, it just messes people up. And then we have minus 4 times what goes in place of y?
-2.
Yep, perfect. Again, you could type this right into your calculator. This is probably one you could do by hand as well. End up with 3 times 3 is 9. -4 times -2 is positive 8. I get 17. Questions? Next one, I'm going to go ahead and keep everything in dark green. That stays a 7 plus 2. What am I replacing x with on the top up there? X was the bright green.
3.
Yeah. So then I have to do 3 squared. Notice I put it in parentheses. If it was a negative, I absolutely need the parentheses in there. If it wasn't, it doesn't affect things too much, but it's safer to put it in. And then 2 times, what am I replacing y with?
-2.
Beautiful. Now, what you could do is type the whole top into the calculator and write it down, which is probably the easiest thing to do. It ends up being 7 plus 9, which is 16. Do you agree that we get 16 on the top?
Yes.
And then let's do the bottom. What's 2 times -2?
-4.
Beautiful. What's 16 divided by -4?
4.
-4. Perfect.
-4. Sorry.
Awesome. So those are evaluating expressions. Expressions can be evaluated, not solved. We will be solving in chapter 3. That'll be on your final. Questions? All right, almost to the end. I think we have 3 more. So we're back visiting scientific notation again. So we're starting out with 3.75, and they're wanting me to write it into decimal notation. I gave up years ago trying to remember if negative went to the left or to the right, or positive went to the left or right. I just know negative is going to give me a tiny, tiny number. Negative exponents are going to give me something I do not want to see on my paycheck. And I know if I move my decimal to the right, I'd like to see that amount on my paycheck. I never will, but I'd like to. So I know I have to move to the left. And if I try it and start it and I get the really big number and I knew I should have gotten a small number, I went, oops, I did it wrong. I do it the other way. So I'm going to move back 7 spaces. And then that's where your decimal will go. And then I'm going to pull the answer key up because it's much nicer written on there. It's much neater. Oh, wow. It's just not scrolling well for me. I like the colors on this one better too. Once we do that movement, whoa, that was weird. That's weird. My computer's starting to, I think I have too much memory in here because I recorded the video earlier. Once you do that, you have a 0 point, and then you have 6 zeros, 375. That is not a number I'd like to see in my paycheck, which confirms what I thought it should be. Positive powers I'd like to see on my paycheck. So again, I'm going to come back to the blank one just because sometimes it's easier to watch what's been done rather than do it. So we had 2.4. And I know it's going to become a number I'd like to see in my paycheck. So I know I want to go to the right. 1, 2, 3, 4, 5. It's going to be 2, 4, and then 3 zeros. Which matches what we got here, 240,000. Positive powers are big numbers. Negative powers are small numbers. Questions? It's just jumping around. I don't know why it's jumping around. Oh, we'll do that one together. All right. Like I said, I'd rather work them out with you than have to show you the answers because that's boring. So we're going to combine like terms. This is going back to some pre-algebra skills. If you took Math 0114, you've seen it recently. If it was somewhere in high school, it may have been a while. Like terms are the same variables to the same powers. So for example, I have an x squared here, and I have a negative 3x squared here. The key is knowing that the number before the x squared is a 1. We have this invisible 1 that's written there. Once you know that, what's 1 minus 3?
-2.
2, beautiful. And you can use a calculator for that. I have no issues with calculators. They're a good tool. And then 6x plus 7x. What's 6 plus 7?
13.
Then it just stays x. It's your label. I know there's some people who've had enough algebra who are like, well, maybe it should be x squared. No, that's when you multiply. We're not, and that's not something we go into in this class. So your answer is negative 2x squared plus 13x. You could also write it as 13x minus 2x squared.
Oh.
Yeah, addition's commutative. You can change your order.
Mm-hmm.
Questions? All right, this one, the second one in 14, this is where it's a little longer than the actual midterm will be. There's a lot of parts on these that don't show up on the midterm. We've got parentheses. I've got to get rid of those parentheses. It's called distributive. So I'm going to take this 4 and distribute it or give it out to both terms that are inside there. That ends up giving me 3z. 4 times 2 is positive 8. 4 times negative z is negative 4z. I can do my highlighters now. 3 has a, oh, I should have been able to use my highlighters. 3 has a z in it, so does the 4, but I make sure I highlight the sign as well. What is 3 minus 4?
-1.
Yep. And you can write it as negative 1z or just negative z. Either would be okay. And then there's nothing to combine with the 8, so I just bring that as part of my problem, and you're done. So
-1
negative
z
z plus 8 or negative z plus 8 or 8 minus z. You can change the order.
Mhm.
Or 8 minus 1z. Lots of options. 1z sounds like something little baby wears. Questions? All right. So we've got a table. I believe the tables still show up in the second half too, just because it fits into what we do in chapter 3. We've gotten pretty comfortable with these. They give us the equation. All I'm doing in my calculator is typing in that equation, 4,000. Like I said, your calculators will not be as slow as mine. Plus 250 times, and the first one's 0 months, so I multiply by 0. That gives you the first number, 4,000. Do the same thing again. I'm going to cheat since this calculator's so laggy. The graphing calculators have a nice feature where if you highlight something and enter it, it types it in again for you, and I can just change the 0 to a 1. Kind of cool. You don't have, you can type it all in again though. 4250. So you can fill in the table that way. And if you look at the answer key, it has worked out each one for you. Each one typed in separately gives you these answers. I did want to review how we can do this on our calculator. You don't have to do it this way. We introduced you to the graphing screen. Right below the graphing screen is all the graphing buttons. Y equals lets you type in an equation. You may have something in there from the last time we did this in class. So clear it out and then type in our new equation, which is 4,000 plus 250 times x. X is on the button that's next to the alpha button. It looks like xt theta n. And then I want to set my table. So I go second window, because it says table setup. I want to start at 0, and I'm counting by ones, so that's good. And then I hit second graph, and that'll show me the whole table. Again, on a test, I'd probably do it both ways. I'd probably do it by individually each one, and then type it in and see what my calculator does. And if they match, I feel pretty confident that I'm right. If they don't match, then I'm going to go back and make sure I type things in right in the calculator, look at that kind of stuff. Questions? Oh, then you can answer the questions. I guess I should pull the answer key up so you can see the table. When does she hit 4,500? Circled in green there, 2 months. You're just reading off the chart once you get filled in. After 4 months, it's 5,000. That's highlighted in pink. So once you have the chart, you can answer any question you like. The one that did catch me off guard on the test, because I kept telling you there was only one of these, both of these are on the test, part A and part B. And I apologize for not knowing that. I thought it was just part B, but part A is pretty fast. I'm going to go ahead and make train tracks here. These are the dimensional analysis ones from 2.4. And after we stop recording, I'll talk a little more about 2.4. So I want to tell you guys about that. But we'll wait till we stop recording because the wider world doesn't need to know that. In part A, it's a single conversion. I'm taking 5 gallons and I'm trying to convert into liters. I always make a little note because I need to know where I'm going. And thankfully, they do give me the conversion. 1 gallon is 3.79 liters. The tricky part, not the tricky part, the part you need to get right, gallons is on top. Where does it need to go so it cancels out?
Bottom.
On the bottom. So I'm going to put gallons on the bottom. Liters on top. They told me 1 gallon was 3.79 liters. I don't have to memorize any of that. The thing I need to know is time. And if I cross off gallons, I'm left with liters. Aha! Give myself a pat on the back because I'm almost done. Multiply everything on top. So go ahead and do 5 times 3.79. I can get my calculator, it disappeared on me. 5 times 3.79. 18.95.
Yep, that's what I got.
And they did say the nearest hundredth, which is already at 2 places after the decimal point. Technically, we usually do the bottom as well, but this bottom is only 1, so it doesn't affect us at all. So the first one will be a single conversion very similar to this. Questions? The second one is, again, very similar to this. I think it's still sea slugs. We're taking, I had never heard of sea slugs. I had to actually Google them to see what they were. We're taking 20 centimeters per day, which is pretty darn slow, I think. And I think once we convert it, we're going into what? Inches per hour. So that my ultimate goal is to be in inches per hour. We call this a double conversion. It's a double conversion because I've got 2 different units that I'm converting, but I still don't do any math until the end. I had a few people ask me questions about homework 2.4, and that's where they were starting to run into trouble. They're trying to convert bit by bit. Don't. Do all your stuff and then do multiply the whole top, multiply the whole bottom, divide it out. It's so much easier. It doesn't matter which you do first. I am so used to doing the top first because I've done it for 30 some years this way, so I'll continue to do it that way. First step is to convert centimeters into inches. Centimeters is on top. Where does it need to go to cancel out?
Bottom.
On the bottom. And they did give me in the problem the conversion between centimeters and inches, which, like I said, you're not going to have to memorize any of that stuff. It will be there for you. And they told me that 1 inch is 2.54 centimeters. Get my other color pen to cross off. Centimeters cancels. I'm left with inches. Aha, I'm halfway done. That's a feel-good moment because you're halfway done. You've already got a couple points on this problem. So I'm done with the top half. Now I want to turn days into hours. Days is on the bottom. Where does it need to go to cancel out?
Top.
On the top.
Bottom. Oh,
It was on the bottom, so I go to the top. And I do know how to convert between days and hours. How many hours are in one day?
24.
24.
That's the one part you are expected to know that. Let's cross that off. So days cancels. I'm left with hours. Aha! I'm happy. I've now gotten half the credit on this problem. I've not really done much of the math, but I've gotten half the credit because I've done the hard part. All that's left is throwing it in your calculator. Multiply everything on top, which for once is actually easier. It's just 20. Usually the top's easier, the bottom, or harder, the bottom's harder. Bottom's a little harder on this one. It's basically 1 times 2.54, 2.54 times 24. Getting 60.96. Do you all agree with that?
Yeah.
60.96.
Awesome. And then the last thing to do is take the top divided by the bottom. I will tell you this afternoon in my class, a lot of people flipped it because it just looked like a nicer answer. Take 20 divided by 60.96. We get a really long decimal. I'll write it all out so we can talk about how to round it. 0.328084. Do you agree with that?
Mm-hmm.
Okay. They didn't tell us where to round. I think they do in the test. If they don't, I'll have to accept whatever you decide to round to. I think I added in here somewhere around to the nearest hundredth. So the 8 is the boss of the 2. What does the 8 tell the 2 to do?
Go up.
Go up. So 0.33 inches per hour. That's really slow. It's a third of an inch per hour. Questions on that one? So one will be a single, one will be a double. I'm going to go ahead and stop the recording.